Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest IoT Central webinar. David Oro, your host. I'm the editorial director with IoT Central. I'd like to start our event off today by thanking Vertica for sponsoring today's event. IoTCentral.io is an integral supporter of the IoT Central community, and we are honored to have them sponsoring our event today. That is Vertica, that is. I'd also like to take this opportunity to show our appreciation for some of our other recent sponsors, including Alteryx, Tableau, Teradata, Statistica, and IBM, to name just a few. Past webinars are available on demand at IoT Central. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our IoT. Today's webinar is entitled IoT, Tackling the Data Management and Analytics Challenge. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We'll have 3 panelists that I'll introduce in just a minute. There will be a 10 to 15-minute Q&A following the presentation. This event is being recorded and will be available on IoTCentral.io later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing and presenting them on your behalf during the Q&A portion of today's event. Very pleased to introduce today's speakers, Alex, Walter, and Ben. Alex is the Director of Development of Harbor Research and an expert in smart systems thinking and design. Alex brings broad client experience in strategy consulting, value chain analysis, and research development across a variety of industries, including industrial, buildings, manufacturing, transportation, and telecom. He also has deep experience developing qualitative and quantitative research studies related to the Internet of Things and smart systems. He has helped develop Harbor's research programs, methodologies, designs, and services. Alex is extremely well-versed on the space, specializing in industrial automation and analytics, and is a frequent speaker, moderator, panelist, and contributor to industry events and media publications. Walter is a senior associate at Harbor Research. He supports Harbor's smart system research projects, consulting engagements, including go-to-market strategies, product portfolio analysis, customer use cases, and segmentation, competitive analysis, and environmental scans. Walter's research focuses on emerging data management and analytics technologies with the IoT. In addition, he conducts venue-specific research related to industrial manufacturing, smart cities, connected vehicles, smart buildings, and Ben Smith is a manager on the Vertica product marketing team, where he supports go-to-market planning, content development, marketing campaigns, competitive research. Ben is a Vertica product evangelist, has a background in IoT, and a passion for clean energy and smart building analytics. Data management and analytic tools will be the core enabler of new values created by the intersection of the Internet of Things, people, and the physical world. However, challenges related to IoT data management and analytics are currently hindering the implementation of increasingly complex IoT applications that will drive this value. By providing an offering that addresses these key IoT data challenges, the Vertica Analytics Platform goes far beyond fragmented and legacy systems, simply not equipped to handle the challenges of IoT data. Harbor Research recently authored a white paper on the HPE Vertica Analytics Platform, which details how Vertica addresses the myriad challenges posed by IoT data. Today's IoT Central webinar, you will learn what is really meant by IoT data management and analytics, why legacy solutions are not suited to handle IoT data, how Vertica's key functionalities and ecosystems address the challenges of IoT data, how equipment manufacturers and IoT platforms providers can act as catalysts for delivering IoT data management and analytics solutions. Alex, Walter, Ben With that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Great. Thank you, David, for the introductions. So as David mentioned, my name is Ben Smith, and I'm a member of the Vertica product marketing team. And thank you all for joining our webinar today. Today's agenda will cover the current state of smart systems, data management challenges and opportunities, key IoT data functionalities, and we'll end with a few case study examples. So before I hand it over to the Harbor research team, I wanted to give a brief overview of Vertica for those in the audience not familiar with it. Vertica is a SQL analytics database purpose-built from the very first line of code to handle analytical queries on massive volumes of data. And how does Vertica accomplish this? Well, it is one of the first analytical databases designed using a columnar compression to significantly boost query speed and performance over traditional data warehouses. It also utilizes an MPP scale-out distributed query architecture with no leader node or single point of failure. And it uses what we call projections that optimize database storage according to the types of queries that your organization runs most often, which can dramatically increase analytical performance. So what does all this mean to you? Well, it means that Vertica is up to 1,000% faster or more than traditional relational database management systems and can scale to petabytes of data on industry standard hardware. With our broad ecosystem of technology integrations, you can also utilize Vertica alongside all of your existing ETL and BI solutions like Tableau, Looker, MicroStrategy, Talend, Informatica, and many more. And you can use Vertica through a broad range of deployment models, which I'll cover in a bit. So one of Vertica's key differentiators is the advanced analytics and machine learning algorithms available, and all accessed via SQL interface. In addition to the standard SQL 99 compliant queries like Monte Carlo and windowing functions, we have a number of SQL extensions that support IoT-related data, such as time series analytics. You can also create user-defined functions to run analytics using Java, C++, R, and other programming languages that your organization currently uses. And finally, to support predictive analytics use cases, we've built out a number of machine learning algorithms, such as logistic regression, linear regression, k-means clustering, naive Bayes, just to name a few. And we built these directly into the core of Vertica, all accessed using a SQL function interface. This allows you to create and deploy and manage predictive analytics models over incredibly large data sets without the need to downsample or move data across different tools and platforms. And all of this is really meant to increase the speed with which your organization can bring predictive analytics solutions to market. As I mentioned earlier, Vertica's core software-only SQL analytics engine can be deployed in many different environments. You can run Vertica on-premise on commodity hardware, in the cloud, including both AWS and Azure, and directly on Hadoop clusters with native support for Orc, Parquet, and other file formats. Vertica is not an appliance, and these aren't different products built for different scenarios. It's all the same core Vertica experience, just deployed wherever your data needs to be analyzed. So we try to be very agnostic in terms of how you can use Vertica to match however your organization is currently storing data. And finally, I just want to provide a few small examples of the many data-driven organizations that are using Vertica for their advanced analytics use cases. In addition to a number of customers using Vertica for IoT, we have customers across a broad spectrum of industries, including financial services, retail, healthcare, gaming, ad tech, and a lot more. And with that, I'd like to hand it over to Alex Glazer from Harbor Research to talk about the current state of smart systems.
Great. Thanks, Ben. And good morning, everyone. First, I'm going to start off. You've probably heard the term smart systems, Internet of Things before, but I think it's really important that we stop and just quickly define how we look at this opportunity. This idea of connecting devices has been around since the late 80s when we were looking at the grid. But what's happened in the past 5 years is that we've seen advancement in areas like sensing. So, for example, on the upper right, you'll see sensors. And what we're doing is we're digitizing physical inputs. So whether it's vibration, temperature, location, pressure, we can now take the physical world and turn it into a digital world. Once we get those inputs, we need a network to improve or transport that data somewhere. So when we look at the networks today, there's new networks coming out like narrowband IoT, low power wide area. But all that really matters from the concept of IoT is that we need a network that's dedicated to transporting the data that we just digitized. Then lastly, where we see the real value in IoT is actually around applications and services. You cannot do anything with value in IoT until you can get access to the data and leverage that data in your businesses or in your processes regarding your business and the people that you're working with. And so when we think about applications, we're thinking about energy management or supply chain and logistics or security management. All of these different applications are enabled once we're able to sense what's going on in the real world, provide a network, and then look at these through different applications and services. Next up, when we think about the current state of smart systems, there's really 5 areas that one has to think about. So I'm going to start at the top and look at technology. So we were just briefly touching on the technology stack that you have to deliver. The second thing to highlight would be the markets. So depending on where you're looking at opportunities for smart systems and Internet of Things, it's very dependent on the market. So whether I'm looking in buildings, transportation, infrastructure, smart cities, markets have very unique requirements when it comes to these different applications and services and tools. The last part of this would be around business models. So if I think about how I'm capturing data, then I have to think about how I'm applying that into the business. But if I can't think about user experience, so for example, I can have the greatest technology in the world applied in the hottest market, but if I have no way to make money or explain or use that data in a seamless user experience, then I've just created a great little technology in a box. The last piece that we see as part of the smart systems and Internet of Things stack is focused on relationships. So we believe that as you move forward in these different markets and technologies and business models for IoT and smart systems, it's really going to come down to the core of your relationships. So what we're going to do is we're going to walk briefly through some of each of these different elements that I was just highlighting. So for example, I'm going to start with user experience. So when we think about context or we think about interactions, so one of the areas that we're seeing kind of come to the surface today are pilots in augmented reality. This is a new form of interaction with data because as you're going through an environment, you have information being displayed in your glasses and you're able to use swiping or eye tracking to actually interact with that machine or device. Other areas, that you look at around tablets or mobile phones, this is all around how does the user actually interact with the data that's being produced from the machine. The technology is the next phase. So when we think about connectivity and enablement, we're really looking at enabling a device. So if I'm looking at a turbine inside of a power generation facility, I have to have some sort of intelligence to allow myself to sense and enable that device. Then I have to have the network. And then the 2 areas that I didn't talk as much about that I'm going to highlight here are system applications and value-added applications. So when we think about system applications, we're really thinking about data management, data aggregation, application enablement. So these are sort of the way I look at this is, it's the applications to allow for a system to move forward. The higher areas around value-added apps are really looking at analytics, mobile and collaboration, asset management. So without those system applications, I can't enable those value-added applications. When we look at smart systems and Internet of Things from a landscape perspective, we're really highlighting areas like buildings, healthcare, resources including agriculture, oil and gas, telecom and professional IT, consumer and professional, retail and commercial services. So this could be anything from, looking at hotels and restaurants, all the way back to supply chain, transportation around connected vehicles, both air and water and on land, and then industrial manufacturing and energy. As we look at the business model piece of the stack, there's a couple things I just want to highlight. So we believe that 2017 moving into 2018 is the time when companies will finally start to understand how to monetize off of the data that they're now starting to manage. And so one of the key pieces around monetization is whether it's cost plus, value-based pricing, what are the different pricing models that will inform these new opportunities, and how will companies work with their customers to drive these new pricing models? When you think about relationships, so whether it's sourcing a technology, it's driving a new channel partnership, or a interesting customer relationship to look at advancements in your technologies, all of these pieces come into play, and it's really important to keep an eye on who you're working with and why you're working with them. So I'm just going to briefly hit on a couple of things that you have to consider when you're driving new smart systems and services. One is that you have to engage these partners that I was just speaking to. You have to think about failing fast. So you have to accelerate delivery very quickly. Don't get caught up in red tape. Don't get caught up in large R&D department processes with stage gates and reviews. Get messy. Find prototyping as second nature in these project developments. And really try and prioritize your investments so that when you're looking at the different opportunities, you're really understanding what are the catalytic maneuvers that your company can make to actually drive these new smart systems and services. So before I hand it over to Walter, I just wanted to highlight Harbor Research. So we're a research and strategy consulting firm that is focused on new growth opportunities that are informed by the Internet of Things and smart systems. Today, we kind of look at our offering in 3 tiers. So we have a research service that people subscribe to. We drive new strategy consulting projects. And then we also have the Smart Systems Lab, where we're working with innovators and OEMs to incubate new technologies. The last piece would just be our communities. So I think what separates Harbor Research is that we work with 3 different types of companies. We work with innovators who are driving new technologies in this space, who are kind of pushing the edge of innovation. We work with large vendors of technology, like information technology, like HPE Vertica. And then we also work with a lot of equipment manufacturers. So over the last 5 years, we've done 65 business cases looking at new smart services and smart systems for product manufacturers like Schneider, like ABB, like GE, Honeywell, and so on. And so given that, we kind of sit in between all of these different elements of the market and have this kind of bird's eye seat of what's really going on. And so with that, what I'm going to do is I'm going to hand it over to the lead researcher and senior associate at Harbor Research, Walter Scheib.
All right, thank you again, everyone, for joining us today. So before we really dive into the key elements and functionalities of data management and analytics solutions, really just want to level set and define what we'll be discussing and where it fits within the IoT gathering, transportation management, and analysis process that Alex was just discussing. So there's many different views on what data management and analytics actually means. So we want to clearly define how we view this space. We define data management and analytics as the integration and exchange of machine and business data to generate insight and achieve business outcomes. This has to do with asset data being collected, transferred, and combined with business systems data to diagnose, predict, prevent, and optimize equipment, processes, and events associated with the business operations and product and service deliveries. Now looking at this graphic on the right here at this process, what we'll really be focusing on today is in the middle there. It's the importance of data transformation and integration. We've seen that this step can account for almost 2/3 of the total time and cost for this whole process. So solutions that can dramatically reduce this time and expense while also providing advanced analytics is critical for customers who want to efficiently derive value from their IoT data. So moving on, looking more at key data management functionalities. As I said, data management is really an often overlooked but critical element to driving value from IoT data through analytics. So here we just want to provide a quick, deeper look at the functional elements within a data management solution that are really required for effective data management that ultimately enables value-added applications and real-time analytics, as Alex mentioned. So just sort of a quick overview of these major features here. So edge data management and analytics, more and more data is increasingly being managed and analyzed at the device or the gateway level, or the edge as it's commonly called. So these offerings are typically comprised of software embedded in field devices or gateways to filter data, alert to faults, and conduct other analyses in near real time at the device level. Moving from there, data cleansing really ensures data accuracy by making sure all data formats are easily uniformed. Data normalization is organizing data into similar scales and magnitudes so analytics can be easily conducted on it. data sorting and encoding. It's ordering the data in a logical manner that allows for quicker and more efficient queries and analytics. Semantic assignment really has to do with using metadata to easily organize and combine different data sets. Data compression and storage. This is compaction of data for more efficient and cost-effective storage overall. And then all of this sort of finally goes into data aggregation and integration. So after completing these steps, you can more easily integrate multiple data sets and conduct analysis, which is where, as we said, the true value of IoT actually lies. Moving on, there's huge promise here, but there's also quite a few challenges related to data management. And those who are trying to derive value from their IoT data are starting to run into these challenges quite a bit. Because machine and sensor data tends to be noisy, analog, and high velocity, there are many challenges that traditional data management analytics tools and techniques just don't handle well. This is especially true if you want to integrate streaming sensor data with historical structured data to get near real-time analytical insights. Legacy data management and analytics offerings, which were built for a pre-IoT world, are not equipped to handle this deluge of structured and semi-structured data that's coming from all sorts of different sources like machine logs and sensors and the myriad other devices that are out there today. But fortunately, emerging data management and analytics solutions can address these challenges much more quickly in a significantly more cost-effective manner than ever previously possible. These solutions are really purpose-built, as Ben mentioned earlier with Vertica, to address IoT data challenges, saving users time and money and rapidly integrating data from IoT sensors and machine sources and deriving new value from that data through advanced analytics. These functionalities are also enabled increasingly complex applications and collaborative ecosystems, which now I'm going to pass it back to Alex to discuss a little bit more.
Yeah, so what Walter's talking about is sort of this transition between simple to what we see as simple, compound, and complex applications. And, you know, your old data management tools could have survived in very simple applications because these were functional alerts and alarms or very basic device tracking. But as you look at where customers want to take data and move forward, the complex applications are where I'm taking many simple applications and compounding them. So, for example, if I look at a building today, in the past, HVAC unit, I would just monitor the HVAC unit, or I would just monitor the electrical power systems. Today, many building owner and operators want to combine data with weather and other things, people movement, to understand how a building is acting almost as a whole ecosystem. And so they're trying to hybridize different pieces of the building, so whether it's people moving and energy all into one view. And so in order to do that, we do need more advanced data management tools. And one other thing I'll just point out before I pass it back to Walter is that depending on which applications or which markets you're looking at, the real value in IoT is in compound and complex applications, but it's still very early on in the market. And so as we move forward, we will continue to see new applications arise that we may not have foreseen before, but as a kind of result of that, these tools will need to be able to respond. And we think that Vertica's done a nice job of designing a set of tools and systems that will allow users to do that. So with that, I'll pass it back to Walter.
Yep, exactly. And just echoing what Alex said, so being able to enable these complex applications and increasingly collaborative business models is only possible if you have the right tools. And now moving forward, we see Vertica as really having quite a few key functionalities that are absolutely critical to managing IoT data. Due to the integration of these functionalities detailed here on this slide and a strong third-party ecosystem, Vertica is really well positioned to efficiently manage large amounts of IoT data and then gain insights from this data very quickly. Vertica accomplishes this by integrating these key components to address the unique needs and challenges related to IoT data sets. So just a quick overview of these key functionalities. First, the Vertica solution integrates easily with Apache Kafka, to handle the challenges of continuous streaming data from IoT sensors. Now that data is being gathered constantly, you need to be able to quickly derive analysis from that data, and it goes stale, for lack of a better word, very quickly if you're not able to stream this data in and analyze it in almost real time. So it's extremely important to have that easy integration with Apache Kafka. And also easy integration with multiple open source solutions that are widely used today and are increasingly popular, including Apache Spark, just to name one. Moving forward from there, really the ability to manage and integrate multiple data types, including messy semi-structured data that may come from industrial machines, for example, and sensors associated with those. Geospatial location data, which is obviously extremely important for mobile assets, and then temporal time series data, which when you have devices gathering data from all over the region or the world, there's different times involved here, different time scales and time zones and things like that. So just making sure all of that is on the same page is really important, and as I mentioned, another key feature that Vertica provides. In addition, the solution has built-in machine learning capabilities that allows users to build models that are trained using historical asset data, and then these models, once they're trained, are deployed to run on near real-time streaming data for a variety of applications. So based on these key IoT functionalities, we'll now take a quick look at sort of a comparison between Vertica and a legacy data warehouse. So first, we consider a legacy data warehouse to be sort of a general term for data management solutions that were built for a pre-IoT world and are not really equipped to efficiently manage and analyze the deluge of data from machine log sensors and other devices coming from a wide variety of industry verticals today. So first, comparison on this slide here, Vertica is built to handle data on a petabyte scale, which addresses data volume challenges that are faced by increasing connectivity and sensing of assets. It leverages both batched and near real-time streaming data through integration with Apache Kafka, as I mentioned, and is able to handle diverse data sources that are commonly seen in IoT environments. Whereas the legacy sources are really just focusing on historical batch data, which is when you're trying to do analytics just using historical data, it's primarily reactionary, and you're not getting the most out of that data that you possibly can. And also, if you're only able to manage and analyze structured data, you're going to have issues as well if you're not able to analyze and integrate geographic data or time series data, machine log data, etc. And then continuing this comparison here, this is really focused on the data storage elements and analytics. The built-in machine learning capabilities leverage both historical and near real-time data to allow users to build and implement machine learning analytics models on their data. And ultimately, when you factor together all these previously mentioned components, it allows Vertica to perform analytical queries anywhere from 50% to over 1,000% faster, really depending upon the variables involved with the data set and required analytics, etc. But this saves a huge amount of time for customers who not only they want to sort of move beyond doing the baseline queries and be focusing more on increasingly complex queries that will drive more value from there. So since they're able to do these queries faster, they can perform more complex queries overall. And now we just want to share a few examples of how Vertica is helping several of their customers manage and analyze IoT data. So first starting out with Optimal Plus, which is an industrial analytics solution provider for the semiconductor and electronics manufacturing industries. The company works with virtually every top silicon manufacturer in the world to provide analytics to their manufacturing process. So the big challenge that they've been facing are increased levels of sensing and connectivity have led to the amount of manufacturing sensor data that Optimal Plus gathers doubling approximately every few years. So there's a massive amount of data here. And this massive data volume has quickly outpaced the abilities of the company's legacy data management solution and really hindered Optimal Plus's ability to provide customers with appropriate near real-time analytics, which is extremely important within manufacturing environments, especially related to silicon manufacturing, because these are extremely expensive and mission-critical production environments where any sort of downtime or defects can lead to huge costs. So the impact of the Vertica solution really allowed Optimal Plus to leverage both historical and near real-time data to create a historical data baseline and then develop models from this historical data. And then they deployed these models within customer supply chains and were able to provide near real-time analytics that was able to alert the customer to any potential manufacturing defects that were going on. Beyond that, Vertica also enabled Optimal Plus to create a holistic view across both the data of the electronic systems and the semiconductor components they contain, allowing for quick identification of the root cause of manufacturing defects, which, if anyone who's on the line is familiar with manufacturing environments, you can relatively easily sense where an issue is happening, but getting to that root cause is extremely complex and requires integration of quite a few different data sources. So that's exactly what Vertica helped Optimal Plus do in this situation. Optimal Plus's customers have experienced immediate ROI once they implemented the Vertica-enabled Optimal Plus solution into their manufacturing environments. And amongst other things, these customers were able to increase production batch yields and also more quickly identify costly defects of the silicon and electronics they're manufacturing. So moving on to the second case study is Anritsu. Anritsu provides products and services for the development, manufacturing, and maintenance of communication systems for mobile phones and internet connectivity. The main challenge that they were facing was reactionary analytics was no longer acceptable to their customers. So that goes back to the historical analytics that I was talking about. So a solution that enables near real-time analytics was needed, they quickly realized. To meet this customer requirement, Anritsu needed an analytical database that enabled the same data-intensive analytics solutions that they currently provided, but these analytics needed to be much quicker, but also at a comparable price to their legacy solution. So Vertica really allowed Anritsu to implement a scalable, cost-effective analytics solution that offers fast data access, allows the company to implement predictive analytics solutions that were really only theoretical until now, including enabling new IoT-specific offerings related to mobile asset connectivity, security, and asset monitoring and behavior applications as well. Anritsu's already realized rapid ROI after implementing Vertica in place of a legacy Oracle solution. They've realized a 351% ROI with a payback period of just 4 months. And then our last case study here is focusing on Suunto, which designs and manufactures sport and dive watches, along with other instruments for a wide range of adventure sports activities. Suunto really wanted to leverage real user data, not just rigid and outdated training algorithms, in order to provide users with optimal training regimens as they're training for athletic events. Since Suunto gathered 20 to 30 million individual training sessions per month, management and analysis of this data in near real time was a huge challenge to delivering the solution that they wanted to deliver. Vertica, once implemented, has allowed Suunto to organize over 1 billion data measures and cluster subsegments of this data in a manner that allows for meaningful performance evaluation and improvement that is based upon real user data. Suunto can now combine a variety of data measurements from devices and users to instantly provide summary performance data, peer comparisons, and personalized training regimens. Suunto's customers are also now able to improve their performance through near real-time comparison with peers, while also receiving data-driven guidance on how to properly reach an exercise goal. So those are the three case studies we wanted to hit on, and sort of the summary overview of how we see Vertica really addressing these major challenges within this space. At this point, I just wanted, before passing it back to David, I just wanted to highlight a few things here. If you want to learn more on any of these topics that we touched on today, we've recently published a white paper with Vertica on pretty much this story that we've told here that takes a deeper dive into pretty much all of these elements detailed throughout this paper. You can download the white paper at vertica.com/harboriot, and it's entitled IoT Challenges Require a New Approach to Data Management and Analytics. So it's available up on the website now for anyone who would like to access that. As far as our presentation goes, that's all we have from our end. So I know now that there are some questions coming in, so I'm going to pass it back to David for that.
There are a lot of questions, and thank you, Alex, Walter, and Ben, for that excellent presentation. We're going to get started today with today's Q&A session. I want to thank the audience for their participation. We have a lot of questions that have come in during this, and we'll do our best to get through all of them in the time remaining. During this Q&A session, I'll leave up this screen with contact information for Alex and Walter and Ben if you'd like to contact them following today's webinar. Let's get started with some of the questions here. And I'm going to start with questions about Apache Kafka and Spark. There was several questions on this, and I was wondering if the question was, can we use Apache Kafka or Spark to stream data into HPE Vertica? There was a slide on that in 27, but maybe there's a little expansion that we can give on that.
Sure. Yeah, I can take that. So with Vertica, you can integrate both with Kafka for streaming data and Spark for bidirectional connections between Vertica and Spark. So you can actually push data from Vertica into Spark and then also Spark into Vertica. We also have, in general, Vertica is very collaborative with the open source community, as you can see from our integrations with Kafka, with Spark, with Apache Hadoop. We even have many engineers on our team who contribute to the Apache project. And actually, in our latest 8.1 Vertica release, we enhanced quite a bit our integrations with both Kafka and Spark 2.0. So yeah, glad people were interested in that question.
Okay, another question coming in is you alluded to some hurdles to implementing analytics solutions. Can any one of you elaborate on this?
Yeah, this is Walter. I can take that one. As far as hurdles goes, there's sort of two common scenarios that we'll see in the market today. First, we'll see early adopters of big data solutions have simply just been gathering these massive amounts of data for a few years now, but they don't really know how to derive any value from this data. This typically happens because they thought that the analysis and insights would come easily, and they didn't really understand the massive requirements related to data management that must be implemented before you can even conduct analytics. So some companies are sort of starting to learn this now, but it's been a challenging process for sure, and that's really why within the webinar we wanted to highlight the challenges and costs related to data management, and then focus on how Vertica is addressing these solutions. Second scenario we'll see sometimes is equipment manufacturers will attempt to build their own data management and analytics solutions because they feel that they know their assets best and can therefore produce the best analytical tools to analyze data coming from their assets. However, again, it really ends up being much more time-consuming and expensive than they originally thought, as they become overwhelmed with data and just really can't effectively manage it or get any sort of value from it. So once they realize that these in-house solutions don't work is typically when we'll see equipment manufacturers turning to third-party solutions like Vertica. As I mentioned before, there's quite a bit more on these challenges and solutions within the white paper as well.
Yeah, so that kind of related to that question is somebody asked about what are the IoT verticals. Are you seeing, can you identify a few of these verticals and also talk about who's any verticals or industries getting it right, or is it just sort of all over the place of one vertical and one company getting it right versus another in some other industry?
Sure. Well, I would say that across pretty much all industry verticals, adoption is still pretty uneven at this point overall. But I would say if you're looking for hotspots, I would certainly say industrial manufacturing is one that's starting to push things forward. But again, within different manufacturing environments, levels of adoption can really depend. We're seeing higher levels of adoption in any environment that has more mission-critical assets or machines. So, for example, if you're a company like Flowserve, who's one that we see is doing some interesting things in the space as far as analytics go, if they have a $2 million pump, you know that they're going to be focusing quite a bit on ensuring that pump, maintenance is done, predictive future maintenance is done on it before anything even breaks down, because that asset's absolutely critical to their whole processes. So that's one player that's doing something interesting as far as industrial manufacturing goes. Trying to think, Alex, any
so the other thing I would just highlight is that when you look at the scale of mission criticality, so in areas where there's more mission critical environments like oil and gas or energy in the grid, monitoring of these systems has been going on for a long time. I think where you're starting to see new tools be introduced are places in like power generation stations, or even in solar. We're seeing some interesting companies like LightSource who are looking at home energy management as a result of these different solutions. And so when you look across the landscape, I agree with Walter. It is fragmented and kind of uneven, but in those mission critical segments is where you're seeing more of the adoption.
Great, thanks. Another question in terms of, I guess, ecosystems is how do you see collaborative data-centric ecosystems forming, moving forward?
Sure. So much of this value around collaborative ecosystems will be driven by integration of currently disparate data sources. And this was sort of alluded to earlier by Alex when he's discussing the transition to increasingly complex applications. But today we see a lot of data and a lot of companies who are gathering this data just sort of siloing up this data and not really allowing it to be integrated. Making sure you have tools that can easily integrate this data are extremely important if you're going to be forming collaborative ecosystems. And that's beyond that, there's certainly questions still around data ownership that really vary from industry to industry. But as these disparate data sources become increasingly integrated and open, players who sort of have or companies who have the groundwork in place to effectively manage and integrate multiple data sources will have a real advantage here.
Great. No, we're getting several questions now about specifics to Vertica. So question is, can we use HPE Vertica for OLTP applications, replacing RDBMS like Oracle, Postgres, MySQL Server, DB2, etc.?
Yeah, good question. I can handle that. This is Ben. So Vertica is not an OLTP database, so it's an online analytics platform. So customers really choose Vertica because they need to run complex queries and analytics on really large data sets. I just mentioned that some of the traditional OLTP database vendors have tried to sort of fork their systems to support analytical queries in addition to the transactional ones, but Vertica was really purpose-built, as I said, to perform faster analytics on large data sets. So Vertica is not an OLTP database.
Okay, great. So again, more Vertica questions. What if we wanted to integrate Vertica in an ecosystem like Hadoop? Is it possible?
Good question. Another one I can handle. Yeah, so there's a few different ways that Vertica works with Hadoop. We do have a Vertica SQL on Hadoop offering where you can actually deploy Vertica's SQL core engine directly on your Hadoop clusters if you want to add SQL analytics and parallel processing to your Hadoop data lake. Other customers also like to use Vertica alongside their Hadoop cluster, so maybe using Vertica for hot data that you really want to analyze quickly and run complex queries on, and maybe offloading older data into your Hadoop data lake. So there's a few different ways you can work with Vertica and Hadoop together.
All right, Ben, you're still on. I have another question on Vertica that you probably could answer. The question was, where can I get more detail on any machine learning features with Vertica, like regression or clustering?
Good question. I'm glad people are interested in that. Where's the best place? I would say go to, if you go to vertica.com and navigate to our resources page, we do have a white paper available going into detail on all of our machine learning algorithms with Vertica. We also have a number of more technical resources available. If you go to my.vertica.com, we've done a number of, our engineering team has produced a lot of documentation and blog posts specifically on those machine learning capabilities. So I would definitely recommend utilizing those resources for more information.
Yeah, and so there's also a question for Vertica solution for in-database feature design and selection for machine learning. I imagine those same places could, I guess, look for that sort of solution somewhere that you just mentioned. Yeah.
Yeah, I would go to those same documentation and resources for all the information related to our in-database machine learning capabilities.
Okay. Shifting gears from Vertica here. Thank you for that, Ben. Another question is a little bit different from what we've been discussing, but I'm going to ask it. What would you say that ad technology and online fraud analytics in terms of ecosystem, is it still early in the stages of IoT adoption and big data analytics? I guess the question is really about ad tech and fraud analytics. You guys looked into that much?
Yeah, no, it's a good point. So the reason that ad tech is so interesting to us is because it has become more device based than in the past. So you're thinking about a consumer moving around with their phone and being able to have instant ads pop up based on their location. The thing that I think we're trying to highlight in ad tech, that I'm sure where this question is coming from, is just the sheer amount of data that these users produce and these systems have to handle. And so when you think about data management in that context, it's about the different data types, so structured, location, spatial, driven by all of these needs. And so if I'm trying to target a given area or target a given persona or user or consumer, it's being able to sparse that data in ways that I can actually start to really cut out where different users are in their preferences. Now, with regards to security and privacy, this is one of those topics that we could probably have a whole separate webinar on, just by the sheer unknowns and problems and challenges we faced in that market. But from a security standpoint, the way we look at security is whether it's the device, the network, or the application, there's different approaches that you have to take for each of those. And so when you think about security in the context of ad tech, it's the security not only of the information that you're getting from this user and their purchasing information, but it's also their privacy around location and preferences and all these different things. And so when you take the sheer amount of data that's being produced, the kind of tools that we're trying to leverage from the old world and the new world on security, it can be quite a challenge. The way that we see people overcoming this challenge today is through partnerships. So it's finding those key partners, whether it's around information, whether it's around data management, security, things like that. It's being able to understand that in the long run, you're never going to be able to solve all of this together. You actually have to work with these partners to address these problems as they come up in sort of an ad hoc and planned nature.
Great. I got time for a couple more questions. So somebody made a comment here in terms of regards to simple, compound, and complex. In a world of outcomes-based design, it appears as though the apps continuum described has more to do with design than effect. I'm trying to put that in my head. Maybe if you need me to reread it, I can put that back into words. But I think it's in a world of outcomes, design, it appears as though apps continuum described has more to do with design than an effect. You guys want to comment on that?
Yeah, I'd love to comment on that. I think it's actually both. So when the design you have to, so I'm going to hit on both of them just because effect does have a huge impact when you think about as far as money, revenue opportunities. Compounded complex opportunities are going to provide a lot more revenue than just the simple based apps, but I'll explain that in a second. So on the design aspect, so when you think about a different system coming online from a standpoint of, if I'm going to go take, I'll give you an example. So in the past, when you think about a truck that's driving down the road carrying pharmaceutical goods, you had three types of networks. You had the driver land-based radio network for communication. You had the in-car network for the actual engine, so CAN bus, being able to look at the telematics data. And then you had the truck's, cab, the trailer was probably a refrigerated unit because it has to be above 60 degrees. And so they're monitoring that to ensure that throughout the course of that trip, the temperature didn't drop, so the drugs were still safe to use. In the past, all three of those networks were kind of sharing different data. Now, if I start to actually combine that data, I have to think about what the purpose is. And so when we talk about design, we're actually thinking about not just the dashboards and how I'm going to leverage the data, but who are the users that need that data and why. And so when we think about the data and we think about location of that truck and the usage and all these different things, we have to keep in mind that we're designing a new application to be able to improve whether it's the route optimization or the actual truck design, the drivers, how are drivers supposed to perform? Are they performing correctly? Things like that. Now, with effect, I want to take that same example. And so when we think about revenue opportunities, we think about smart services, a lot of product manufacturers in the late 90s and 2000s created very, very basic remote alarms monitoring. And so they were able to increase their service contracts. They were seeing margins of 15 to 20% more than they had before just based on products. And they were kind of, as we say, getting drunk off the margins. That's first base is, wow, look at this. I can get a renewal, a recurring service contract, and, once every 18 months it pops up. But other than that, we're just making money. The issue is a lot of customers want more. So as the spec of these systems is shifting to end customers, they want to be able to do more with data. And as a result, the product manufacturers need to be able to respond. And so when we talk about driving new services and the effect of this, we're really looking at the ways that we can improve how our customers are using our products. That does two things for us. That increases the data and allows for us to understand the usage so that can feed back to design. But it also drives a more intimate relationship with that customer. If I can understand how a customer is using that product in many different ways and during different times of the day or week or month, I can start to actually provide other services to support that usage, which in turn leads to more revenue. So I think it's a mix of both between design and effect, but I could understand how someone could see that the way we were describing it before with simple, compound, complex is really about designing the systems. But really, the revenue opportunities become much greater, say, in a city when we're integrating all of these systems from an effect standpoint and things like that.
Great. We're coming up to time. Maybe one more question on a simple question, really, on Vertica, and then I have one more closing out issue for you guys in terms of the research. So, question was about Vertica's any use cases in the energy sector, energy sector, excuse me.
Yeah, good question. So we do have customers that are using Vertica in the energy sector. Off the top of my head, I know Trane, which is an HVAC equipment manufacturer, uses Vertica to analyze some of the sensor data coming off of their equipment, their mechanical equipment in buildings. And I believe they do that mostly as part of their service work to their end customers. Estia Energy is another customer of ours. They're a utility in Europe, and they're using Vertica to analyze. I believe both. They're using Vertica to analyze data that they have.
Great, thank you, Ben. I think the last question here is for Alex and Walter. So, what are the key issues headed for IoT? Where are you guys going to focus your research here in the future? What are the challenges does the industry or industries face?
Yeah, it's a question we get asked quite often. So we highlight really 3 areas. I'm going to start with the one that people are probably most familiar with is interoperability. And so one of the big challenges we face today is looking at many of these disparate systems or silos of data that Walter talked about. And you know, it's being able to actually drive interoperable systems and applications across many of the different products and tools that we're using in these different environments. The second one that I would highlight is business models and monetization. I think one of the biggest problems with IoT today is that we're sort of stuck in pilot mode. So when you think about where IoT came from, it was a lot of different technologies. M2M is what it used to be called, and it was just the concept that you were connecting many machines so they could communicate. Now that people want to get involved and we have new services and systems that we're trying to deliver, the problem that we're facing is how do we actually monetize those services? So we work with an industrial gases company, for example, who says, you know, well, we want to add more services, but we're already giving away some of that for free. How are we supposed to all of a sudden start charging them? So it's thinking creatively about the different ways that you can actually provide these new services and new systems. And this really comes back to the third challenge or opportunity, which would be ecosystems. And so Walter hit on this earlier around data ecosystems. I will just hit on this around just overall general ecosystems. We have to find a way to design partnerships where both parties benefit and can monetize on these opportunities. And I think one of the problems that we're facing today is that people are just trying to figure this out internally, how they want to drive their new digital and IoT strategy, more or less. And when they start to think about the market, they get paranoid that their competitors might be competing and they have to be very cautious about what they put into the market and who they partner with. And I think that what people will start to understand in the future is that you will move so much quicker to market if you can actually find a partnership model that will actually work for you. And this is why we think that Vertica has done a really nice job in the way that they're working with their customers to actually partner and drive new kind of tools into these systems. But again, just to highlight the 3, it's interoperability, it's the monetization behind business models, and then it's driving new forms of partnerships to inform these smart services and opportunities.
Alex, Walter, and Ben, thank you to some great answers to some very good questions. For those of you that asked questions that weren't answered today, we will be sending all unanswered questions to Alex, Walter, and Ben so they can follow up with you after today's webinar. I have just a few quick announcements. Please mark your calendars for May 16th and our next IoT Central webinar, Centric Analytics for IoT. It's sponsored by Statistica. Also, today's taping, many of you asked for about the slides, will be available for on-demand viewing later today and can be found on the homepage at iotcentral.io in the webinar tab located at the top of the page. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and special thanks to Vertica for their sponsorship and our speakers today. Alex Glacier, Walter Scheib, and Benjamin Smith for their insights in today's topics. My name is David Oro, and I'm very pleased to have been your host for today's event, and I look forward to seeing you all again May 16th. Have a great day.